We talked about trusses and frames earlier. Trusses and frames are stationary structures designed to support large loads. A truss is a structure that is entirely made of two force members. These members are either in tension or in compression. This means truss members experience only axial forces. A frame is also a structure designed to support large loads, but a frame includes at least one multi-force member. Unlike trusses and frames, machines are designed to transmit forces, and at least one member of the machine is a moving member. Machines can be simple or very complex. Let's take a look at a few machines that we encounter in our everyday life. Here is an example of a locking plier. Locking plier is used to hold something in place. Devices such as gripping mechanisms or bolt cutters are very similar to locking pliers. In a locking plier like this, you have an upper handle connected to the upper jaw. There is a lower jaw and a lower handle and a connecting rod. There are basically four members, and when we apply a force on the handles, a force is developed between the jaws to hold something in place. So that's a locking plier. Now let's take a look at another device, nutcracker. You probably have a device like this in your kitchen table. This is useful in crushing nuts. This device, although looks very different from the locking plier, is very similar. It has a handle, a connecting rod, and a piston, and in this space a nut is placed, and when I apply a force on the handle, that force is transmitted through this link system to generate a crushing force that ultimately crushes the nut here. As you can see, this is actually a multi-force member. A force is applied here, it is connected to a two-force member here, and it is connected to the ground. So this handle is not a two-force member, it's a multi-force member. All right? Now let's take a look at another mechanism. Here is a can crusher. This can crusher mechanism is typically mounted to a wall. In this case, I have got this mounted to a wooden frame, so I can show you a demonstration. So this can crusher is very similar to the nutcracker. Take a look at it. Here is a handle connected to an intermediate link to a slider, and in this space you place the can. Let me do that now. Here is a can. I'm going to place it here, and I release the handle till the slider touches it. Right now the can is not experiencing any crushing forces because I am not applying any force on the handle. So if I apply a force on this handle, that force is going to be transmitted through this linkage system and generate a crushing force on the slider, which will ultimately collapse the can. And that's exactly what I am going to do now. So here is a simple can crusher. Can is placed, and I am going to apply a force on the handle and watch what happens. So the goal in this particular problem is to calculate the forces, crushing forces developed when I apply a known force, and that's the task. In order to do that, first we have to draw the sketch of this entire mechanism. The sketch will include the handle, intermediate link, slider, and the can. So let's draw the sketch first. After drawing the sketch showing all the parts and their dimensions, we will draw the free body diagram of each member of the system and calculate the member forces. And that will be in the next video.